So first, can everyone hear me okay? In the back? Yeah? Okay, cool. So we work at Very Good Ventures, and we're collaborating with our partners at Codemagic today to talk about testing and how you can automate some of that in Flutter. So before we get started, have any of you heard of Codemagic or used Codemagic before in any Flutter projects? Okay, cool. So we have some people in the room. Hopefully more of you will go home and try it out after this. And yeah, let's just jump right into it. So we have a couple things on our agenda today. So we'll talk about first and foremost, why should we care about testing? Things that we can do to make it easier to test, and the different things that are possible in Flutter. So Flutter comes with a bunch of different tools out of the box that allow you to do unit testing, widget testing, integration testing, so we'll talk about that. We'll also talk about useful tools that you might come across along the way in packages and that sort of thing. And then we'll do some live coding and talk about how to automate all this and actually integrate it all with Codemagic at the very end. So let's get started. And for those of you who want to follow along, we have the link to the repo with all this code. So you can actually go and clone it right now and start following along as we go. Cool.
Should we leave it like 20 more seconds?
Yeah, I'll give you guys 20 seconds to...
If you just go to the VGV Ventures organization, it's called Happy Testing. So easy to spot. Probably it's on the top, yeah, because we just open sourced it before coming here.
Yep. Question?
Do you guys use Codemagic for most of your projects then?
It depends on the client, but yeah, we usually try to recommend it since it's so easy to get started and integrate. But we also use GitHub Actions for CI and Codemagic for CD a lot.
Oh, so you use GitHub Actions, I was going to ask about that.
Mm-hmm. Yeah, we've tried a bunch of different tools in the past, and we keep progressing and picking and choosing aspects of things that we like, and yeah, so far Codemagic has been really awesome for us. Cool. Has everyone had a chance? All right, so why testing? So we tried to break down this question by asking two more questions. So the first question that answers the question of why testing is if I want to basically know that something works right now. So with writing tests comes the confidence of knowing that my code works right this second, right? Like I know I can see it, I can see the green check mark. It also boosts our confidence that okay, we've covered all these edge cases. We can basically manipulate the environment of our code so that we can mock different dependencies and that type of thing. So for the now, it's really useful to write tests because you want to know that what you just wrote works, obviously, right? And the second part is, and the most important part I would argue, is will it work later on, right? So you want to have the confidence that over time, maybe a few months or a few years later, that code will actually continue to work as it's expected, even when hundreds of developers have committed to it and modified it and iterated on that feature. Question?
I'll just add to that. It also helps me upgrade versions.
Oh yeah, exactly. Yeah. Yeah, how can I know after I made a huge refactor that everything still works and it's not just going to fail on me all of a sudden? So testing plays a huge role in that. And also, for open source projects, it's really nice to have tests as kind of a welcoming gesture to people who want to contribute from the community. Because, for example, if I'm out there and I want to add a feature to some open source library, I don't want to be really nervous that, oh, I might have broken everything else that exists there. I like to have that confidence that, okay, every test is passing. I can be reasonably confident that my change actually is going to work and it's not going to mess everything up for everyone else. So it's kind of be a good citizen and write some tests so that other people can feel more comfortable contributing. And lastly, bug prevention, obviously the big one. We don't want to introduce bugs and we don't want to have regression. So once you've had a bug, it's nice to add a test so that you never introduce that bug over and over and over again in the future.
There's an economic aspect of this that I think it saves money. I need the data to prove it. So if someone wants to work with me, let's be millionaires together. I don't know, but I'm convinced that it saves money in the end.
Yeah, definitely. A lot of folks that we've worked with worry that the impact of writing tests is huge at the beginning. You spend 3 times the amount of time writing tests up front, and it's not worth it. Or even from a perspective where you're billing a client, the client doesn't want to pay for the test. But like we're saying, we would argue that over time that really pays off, and even doubles or triples in value over time, just because of the amount of time you save manually testing or fixing bugs in the future. So hopefully we can convince people of that. So moving on, what makes code testable? So there are code bases that are a lot easier to test than others, and obviously you want to be in the camp where you're having a really easy time testing things. You don't want to be struggling and thinking okay, this is a waste of time, it's going to take me forever to test. So we've broken this down and have a couple of bullet points for things that make code easy to test. And at the top of that list is decoupled dependencies. So obviously having code that is modular and doesn't have all the dependencies like lumped into one spot makes it a lot easier to test because you're testing the individual units and not trying to test this giant beast that has like 50 dependencies and you have to mock everything all at once. That also leads into the single responsibility principle. So having every piece of code have a single function, single reason to change, that makes it a lot easier because then you're only testing one thing. You're not testing like 10 different scenarios in a single code base. Yep?
Yeah, so what's the code coverage are you looking at when you're trying to write these?
What's the code coverage? That depends. So that's a good question. We used to work at BMW on a pretty large project, and we had the privilege of starting from scratch there, so it was a greenfield project. And for that one, we decided we want to start off with 100%. But it doesn't mean that the code is bug-free, or it doesn't mean that it's going to be perfect. We just wanted to pick a number that we thought we could like push ourselves to commit to and stick to over a long period of time. If it's a legacy code base, that's obviously really hard to do, like jump in with no tests and say we want to get it to 100 overnight. That's not going to happen, but yeah, I think it depends on the project. But I'd say like try to push like slightly above what you're comfortable with and keep trying to chip away as much as possible over time.
After all coverage means that you're executing that path one or multiple times, and if you didn't have that cover, that means that it wasn't executed as part of your test suite, right? But the way you get to that code, like the way you're coming from a loop or like a set of pre-required, like preset environment variables that are executing that code matters as well. That's why we're saying like 100% coverage doesn't mean that it's bug-free. It means that it was exercised under a certain condition at least once, right? Then you can get even into more like detailed reports about like execution flows and all the stuff. But at least that gives you like a level of confidence that with certain conditions, your code was exercised during testing.
Great question. So yeah, single responsibility principle helps a lot, make code a lot easier to test. Also naming and like making sure things are really clear to people who are going to be looking at that code later. So conveying your intention clearly when you're writing code is really important actually when testing it because it makes testing it that much easier. If we have a function that's just called like foo, no one really knows what it's going to do, no one knows how to test it. You have to start looking line by line at the implementation to write tests for it, or if the tests break, figuring out how to fix those is even more challenging. So clearly conveying your intention when writing code also helps a lot with testing, which is maybe not like the most obvious thing. You might think like, oh, it's just how the code is written, but actually how the code is named and documented has a big impact as well. The second to last bullet point is avoiding side effects. So in my experience, as much as possible, I try to have pure functions that just have a single input and a single output that are deterministic. So every single time if I run that code like 1,000 times with the same input, I'll get the same output. And I find that makes unit testing a piece of cake, as opposed to if I have a function that then reads from a database and then makes a network call, and then if all those things succeed, then it gives me some output, otherwise it gives me some other output. So obviously you still have those cases, but trying to, again, follow the single responsibility principle and compartmentalize as much of that as possible really helps to make testing as easy as it can be. And that leads into the predictable part. So having the code read and execute predictably so that anyone, either someone new or someone on the existing project, can come in and out and feel familiar and understand how the code works is really, really important.
Now this is not easy, right? Like,
Definitely not.
If it was easy, everyone would be doing it, but it's just like a set of principles or a set of guides that if you hold yourself accountable to these standards, it's going to put you in a much better position when it comes to testing, but also welcoming other developers, product owners, business stakeholders, right? Because like code after all is something that everyone can interpret. Like we're having like every day better and better layers of abstraction, and that's something that we've noticed with Flutter as well, right? Where it is very common nowadays to see next to your like designer or product owner to get that code running, right? So having all these set of principles is going to help to kind of like go one step further when it comes to abstraction and maintenance in the future.
So now we're going to take a look at a realistic, somewhat realistic example of some code. So we'll start off as just a simple function that's called getTimeOfDay. It returns a string. And obviously we want to use this function so that we can call it and get the current time of day. And we represent time of day as a string that's either night, morning, afternoon, or evening. So if we break this down, our function is first figuring out what time it is right now. Then we're doing some math to check out are the hours between midnight or 6 a.m. If that's the case, it's night, 6 to 12 morning, 12 to 6 p.m. noon, otherwise evening. So does anyone see any like red flags in this code, or so far so good? All right, we got some in the back.
So I'd be a little nervous about doing daytime about now.
Okay.
And then that'll be screwing up on my page or something. I don't know.
Nice, nice. Yep, very good observation. Anyone else?
You also can't test it because it's only going to return the current time. So you have to ask what is the current time, and then run the test.
Yep, exactly. Yep, same thing. Cool. All right, so we've already got some.
Localizable.
Sorry?
It's not localizable.
Oh, it's not localizable. That's a good point. Yep.
We're not going to fix that, unfortunately.
Next talk.
Localization in Flutter.
Yep. So let's hypothetically start writing some tests for this code that we just saw, right? So we want to write a test that's going to return morning when we give it 6 a.m., right? Just potential test case that we want to have. So first things first is we try to break up our test into 3 phases. We have our arrange phase where we try to like set up everything the way we want it to be before we actually run the test. We have act phase where we actually do the action that we're going to be testing. And then the assertion phase where we're going to start actually validating that the data we got back is correct.
And this is the best recipe, and pretty much the recipe for success at testing, right? Like, testing is also code, so it has to be readable, it has to be maintainable, and like every single test case is going to be composed of these 3 steps. So if you have them arranged or like organized in this order, it's going to help you a lot to just jump into a code base, see the test case, and see what is actually testing the expectation. And if it passes, great, but if it fails, you're going to have immediately in front of you the answer of why it's not working.
Yep. And even if the test seems like it's really complicated at first, in my experience, it's really helpful to break it up into these 3 steps, because then you can start breaking it down and being like, okay, I don't have to really think about like, what am I going to do in the act or assert phase? I'm just going to focus on the arrange phase. And then like once I finish arranging everything, then I can move on and think about, okay, what am I actually going to test? What am I going to assert? And like having this kind of formula helps you like make little progress and like kind of increment and kind of go through all your tests the same way, even if they might be drastically different tests that are drastically different like difficulties and solving different problems. So yeah, I think it's really useful to have that. And immediately, as some people call out, we're going to throw this to do in there because in our arrange we can't actually do anything. We need to figure out how we're going to change the system time in our test so that it could be 6 a.m. before we actually do anything, right? So does anyone here know how do you change the system time in Flutter to be 6 a.m.? Okay, I don't either, so we're going to leave that one. We're going to move on to the act. We're going to basically call our function, get time of day, and store it as a variable, time of day, very descriptive. And then lastly, we're going to assert that we got morning back, right? And one thing that we wanted to call out in this is, in a case like this, you also have to be careful to actually revert everything back to the state that it was in before you started your test so that you don't impact future tests. So it becomes even more challenging with a test like this because now you have to change the system time, but then also reset the system time back to what it was so that you don't break all the tests afterwards. And cool tip, I didn't know this until recently, you can actually run Flutter tests in a random order. You want to talk about?
Yeah, so there's a cool thing, right, like that tests are something that you're going to let a computer, a machine run for you, right, and you want to automate that process. So in order to be even more kind of like thorough about like the way you're testing, you want to avoid, and this is part of being predictable and avoiding side effects, right? Like if you have a relationship between the order of execution of your test, that's usually not good because that might not represent a user flow, right? Or like a data flow or something like that. So with Flutter, now you can append like another command that is randomize your test and give it a seed or use the default random seed. That means that all the test cases that you have in your test suite are going to be executed every single time in a random order to ensure that there's no state dependencies between test cases, which is great because that's what you want to have, right? Like running the same recipe over and over again like gives you a level of confidence, but like doing it in a random way and still working gives you an extra level of confidence.
Exactly. Cool. So we kind of have our structure, but we have some holes in our implementation. And at this point, we might be thinking something like this, like, okay, maybe we just don't write unit tests, right? Like they can't fail if we don't write them in the first place. But we're not going to do that. We're actually going to go back and refactor our code to make it a little more testable. So we're just going to make one change. We're not going to address localization, but that's also a good call out. We're just going to address the dependency on datetime.now. So previously we were actually, question? Oh, no.
Okay, no, I was just
Don't worry. So previously we were actually just calling datetime.now directly within our getTimeOfDay. So it was an internal dependency that we were hiding from whoever was invoking this function. So we're now able to basically lift that dependency up and inject it into the function. And the rest of the code stays exactly the same. But now our tests, we can have them look something like this, where in our range, we actually will just create a datetime object. So in this case, like January 1st at 6 a.m. And we can, again, call getTimeOfDay, but this time we'll pass our arranged time that we just created. And then we can assert that it's morning. So this gives us really fine-grained control over the input of the function, and then we can assert against the output of the function. Go ahead.
This is, of course, a very simple case, but like making code testable can be summarized into actually breaking down your code into smaller chunks of code, moving dependencies around in a way that like all the dependencies have like a unidirectional data flow, or like you don't have dependencies that they don't belong in the place where they're listed, right? So this is a perfect example of just abstracting out one dependency, moving it one level up, and removing that burden or like that responsibility in this method of having to calculate what's the current time. That's not the mission of this method.
Right. Question?
Would it break your test if you made the time an optional parameter for the function? Because you just put back on the developer now.
So you make time optional and default to now, for example, if it's not provided?
That's what I would do, so that the caller doesn't have to do the extra work saying the daytime now, but would that then then I have to write a test for that?
Yeah, that's what I was going to say. So that would allow you to cover like 99.9% of the cases, but you still have that one case where when nothing is provided, does it behave the way you expect? So that's where like it kind of gets iffy. Were you going to say something?
That's also like a trade-off from your API design, right? Like once you're designing these APIs and being mindful about like how is this method or like this class or like this contract going to be utilized, you can start thinking about like what's the right naming convention, like be consistent, right? What are the arguments that I should take? Is it truly necessary that I provide something that is optional? What's the value? Is it going to make it simpler, more complex, more, right? Like all those things are part of the consideration. And I think that sometimes when designing these use cases, we don't take enough time, even ourselves as developers, to think about this thing. We're just kind of like, oh, this is so obvious, right? But what it's obvious today doesn't become like that obvious 2 months later, even 2 weeks later, in my case, 2 minutes later, so.
Yeah, great question. I think a lot of that depends on how you're trying to design the API. Like Jorge said, you might make sacrifices just for the sake of the API being easier to use, but then it's harder to test. So it just depends on your use case.
Quick question.
Oh, yeah.
So the format of time there, that is also going to be something that the end user should be aware of. I could just enter in a 6 there and expect the result to be.
Right. That's a good point. So yeah, at any date right now, as long as it has a 6 in that last place, will give us morning, and our function is just testing that the hours get interpreted correctly, but yeah, that's a good call out. Cool, so this is just a simple example, like Jorge said. A lot of times this is going to actually be way more complicated, but we just wanted to illustrate in a simple example some of the principles or techniques you could use to simplify writing tests. And again, these are just unit tests, so we're going to talk about more than just unit tests. We're going to talk about widget tests, integration tests, which brings us into our layers of testing in Flutter. So, how many of you have written a unit test in Flutter or Dart? Okay, cool, yeah. How many of you have written a widget test? Cool, still going strong. How many of you have written an integration test? Oh, getting smaller. Okay, hopefully that will change after this. But to summarize, unit tests are things like what we just saw that are tests that test just a single function or a single method. And they're kind of like the thing that you think about probably when you think of testing. Widget tests are more associated with UI, so testing an individual component in Flutter. It's still kind of like a unit test, like it reads like a unit test, but it's more for the UI and the presentation. And then the last bit is like the huge big picture test, which is integration test, which allow you to basically run through a huge flow or like maybe an entire application all at once. And that'll give you the confidence that like as a user using this app, I'm getting the experience that I should be getting. So 3 layers. Anyone have any questions about when you would use Like when would you write a test as a unit test versus an integration test? Yep.
So for widget testing, since like the UI might change, and like you guys said that you like testing a lot, isn't it kind of discouraging to like write the test for UI and then someone say, oh, you have to change it?
You will never hear me saying like, oh, don't write more tests. Like I think writing tests is like the worst case that could happen is duplication, or like maybe I don't know. But like in my experience, even if the UI is changing so frequently, with a lot of these things, you're actually not testing UI, and that's very important. You might be testing actually UX, right? You're asserting that button is doing certain things. What's the size of that button? What's the color? I mean, you can test for that, but like most of the time, you might not be exercising that aspect, right? Like it depends how you set up. You're testing what's important for you, what's the strategy, right? Like, but
yeah, sky's the limit for how granular you want to get with your tests. Like Jorge said, you can test color, size, position on the screen if you really wanted to. Again, that comes with the trade-off of like it's way more likely that test will break, and I'll have to keep fixing it over time. But I was also going to say like that brings up a good point of it's really like it's easy to have a lot of overlap in your tests. Like you might test the same scenario like 15 or 20 times, but that kind of discourages you, like you said, because then if one of those tests break, all of those tests break, and that's way more work that you have to do as a developer. And so, at least in my experience, it helps to have only test one thing, so that if I change one thing, only one test fails. I know that's really hard to do, but if you can get to that place, then it makes it a lot more manageable. You're not fixing like hundreds of tests at once. You're only fixing one test or two tests or whatever it might be. So I think like if you can get there, that's great. But yeah, it's not always easy to.
I think one of the biggest challenges of testing is actually not doing the testing. Is actually being efficient about your test, right? Because you will hear a lot of people say like it takes a lot of time, and sometimes it's because the testing strategy or like what you're testing might not be where like most of the value of your product is, right? And that to me is like a very tricky question to answer, because you have to know about your product, even kind of like think about what's going to be the feature of this product, so you can put more energy, more rails or protection around that piece of code or that functionality that is super important that it works, right? But also like it depends on how you divide your code, right? Like if I were writing, let's say, the material library, and to me it's very important that the shadows they have a certain like a splash effect, I maybe want to test everything that is involved with that animation. Yeah. But me as a consumer of the material library in my to-do list application, I don't care. I assume that the material team is already testing that part, right? I just want that it gives me the nice effect. So you have to understand where you put your energy and where to make trade-offs.
So just to kind of make sure we're on the same page, you want to like make sure you have your strategy first, then test. Kind of like your pitch.
Not only for test, for everything. Come up with a plan first. To me, like whiteboards were invented to come up with a plan, not to do coding interviews. So.
That's a great point, and I think one thing that I think gets neglected a lot is we refactor code, but do we refactor tests? And I think that over time, as you figure out more efficient ways to test things, it becomes just as important as refactoring code to go back and refactor your tests to make sure that they're both like easier to understand, more concise maybe, easier to maintain. Because yeah, no one's going to write tests if it's like a pain to modify them or add new ones. So I think that's just as important as anything else. Great question. So next we'll get into some common tools that you'll run into when writing these tests. So the first one, you'll come across it a lot probably if you're just writing pure dark code or if you're just writing regular unit tests, and that's just the test package. They described it as a fully featured library for writing and running dark tests. So it gives you things like the group, the actual test closure, it gives you setups, matchers, all kinds of stuff, and it's pretty much everything you need in one package to write unit tests for dark code. Next one is test coverage. So how many of you that have written tests have also run coverage against the code? Got one, two? All right, cool. So hopefully that will change as well. The test coverage package allows you to basically create a visual report that represents how much of your code has actually been tested, at least in terms of line coverage, not in terms of like branching and other things as of now. But it gives you a good kind of big picture of like, has this code been exercised, like Jorge said, have we executed this code at least once in our tests? So that's test coverage. The next one is Flutter Test. So that's kind of like the test package that we saw earlier, except for it has all the Flutter add-ons on top of it, and this is really useful for widget tests. They've also added a couple of extra like assertion matchers and things like that to make it more convenient to have different expectations. And Flutter driver is for the integration test. So when you're doing like the full end-to-end feature flow and you want to actually like have the simulator or emulator spin up and be able to go through a whole flow of screens and tapping on buttons and all that stuff and see that, Flutter driver will get you there. And you can also do things like analyze performance and take screenshots and other stuff. And there's some cool libraries that Jorge has written that we don't have here, but talk to us after if you're interested to help you profile and take screenshots of your application while you're running integration tests. And the last one we have on here is Mockito. So it was inspired by Mockito from Java, as far as I understand, and it basically helps you stub out and like mock all your dependencies so that you're only focusing on testing the one piece of code that you're focusing on testing. You're not worrying about how do I mock or make sure that all this other stuff is in the state that I want it to be before I test my one thing. And it will definitely come in handy, and we'll see that in the demo after this. So, without further ado, it's coding time.
It's coding time. So, what we're gonna do now is to go through this project that we've shared with you before. And actually, I'm gonna need to mirror the displays. Let's mirror this.
Technical difficulties.
Okay, this was unexpected. Oh, that's okay.
Can we go back?
Let's go back. I can just look at the.
Show's okay too.
Yeah, thanks. I might have broken the.
Wait, try it. Okay. The old. Unplug and plug it back.
Maybe we have to. There you go. Amazing. So let's go back here. I'm gonna make this bigger.
Yeah, can everyone let us know if you can't see so we can make the font size larger?
So
we're doing just fine until.
yeah. Okay, let's unplug again. That seemed to work.
We tried different before.
No, this is the time that it's gonna work. Because science. Alright, so this project, let's run it first of all.
If you clone the link at the beginning, you should be where we are right now, hopefully.
But this is kind of like the next evolution of the counter app, but this one is going to make money as opposed to the counter app that comes with the Flutter project, because this one is tested. As I said, it's going to save us money, right? But pretty much we're going to see a few things. So this is my project.
What is it running on, Jorge?
Oh, what is it running? I don't know.
That's not iOS.
This is not Android either. It's a macOS application running on Flutter. Crazy, right? Okay. So this is just because, so for those who don't know, like Flutter on the beta channel supports web, right? So now you can run your Flutter applications with an asterisk on a browser. The asterisk is like it's still beta support. There are libraries that they don't work, or like if you depend on platform channels. If you change to the master channel, there's support also for macOS. I think actually macOS works great, but they don't want to say that, or they don't want to move it until beta because they want to call it like Flutter Desktop, and they're still working on the support for Windows. But this is like a full-fledged macOS application. Works like a charm, super efficient, super performant. So in this case, it's just a counter, right? It's gonna count the amount of times that we tap this button, and it's gonna give us here a reference. Like very simple, right? Like, number 1 is an odd number. If I tap on, oh, I have a breakpoint, I apologize. Let's give it our execution here. It's okay. Now it says this is an even number, and we can keep going like that. And on top of that, I added some kind of like processing time. It's just a delay on a feature that it's mimicking kind of like if we were making an elbow call, because clearly updating these values very heavy computing on processing on our computer. So I want to kind of like deliver that somewhere else. All right. So everyone is clear with what the application is doing. It's just counting the time that we're tapping on the button and giving us a reference of like, is this an odd number or an even number, right? So if we go back to my code base, we're gonna see that this has the typical like, Flutter structure, right? Like we have a lib folder where I have here my code, like nothing crazy in here, but then we have a few other folders that are a little bit special. We have these packages, we have test and test driver. So in packages, we have something called API and something called repository. We've been talking that in order to be really efficient about testing, it's very important to separate your concerns. And even for this simple application, we're still gonna mimic that we had an API client that we're treating as a separate module. We're still gonna have a repository layer that is what we call our business domain that is gonna do the calculation of if this is an even number, give me the message of an even number, or if this is an odd number, give me the reference of an odd number. And finally, a library holds the application layer, how we present the data from the repository into the screen, right? And then we're gonna see the test and the test driver. Before we move on, I wanted to share this with you. So this is a dependency graph of my Flutter architecture, right? Like this is done with a package called PubVis. So PubVis is a utility done by Google that is going to generate graphs like this. You can print this graph in your terminal, or you can just create actually a web report. And one of the things that I like about this graph is like it actually represents how well, or like how the application is architected. So in this case, we have our application. I call it happy testing. And then this depends on Flutter, and Flutter depends on a lot of other packages, right? It depends also on Flutter and Mockito, but also depends on the repository layer. And the repository layer depends on the API layer, right? So it's very clear what's the kind of like the dependency flow of this application. It's going to have on top of this as the root, right? Like as the main module, my UI, my Flutter project. This repository is pure Dart. So we could have an Angular Dart application, we could have a terminal one-line application, and we could use this repository. And same thing for the API, but the API is just more like, give me the raw data, right? So we're gonna follow this structure from the bottom to the up of the project, right? So we're gonna take a look first to the API, then to the repository, and then to the happy testing.
One last note about the PubVis tool is it also gives you a JSON representation of your dependency graph, so you can actually do assertions like in a pipeline or a CI environment and make sure like, okay, this should never have a direct dependency on Y, for example, and if that happens, fail the pipeline. So you can actually start enforcing some of these unidirectional dependency graphs in a pipeline and not have to rely on like PR, someone having to like catch, oh, you added this to your pub spec, that's bad.
That's a good point. Like in our case, for example, we have in every single project this 3-tier architecture where like we have the UI on top, then the repository in the middle, and then raw data clients at the bottom. So for us, it's a big no-no that the API client is injected directly into the application module, right? Just because we're skipping that business logic. So we can actually write kind of like defensive code in our pipelines to make sure that this 3-tier architecture can be honored. So let's go back to our code, right? We've seen the feature, and let's start with the first package, that is the API. So this is a pure Dart package, very simple. It has a library and a test folder and a pub spec. In my pub spec, I just have the test library as a dependency, as Felix explained before. This is what you use in Dart to test your code, right? Let's take a look to the implementation, very simple. These are just kind of like library exports that helps me organize my package into a library format, but like pretty much, this is very simple. We said that it's mimicking an API that is incrementing this value. I'm faking it, right? Like I'm not making a network call, but like now I move all the code in such a way that I could inject in here an HTTP client, a gRPC client, whatever I wanted to do real-time communication. And my code would still work as well just by honoring that dependency, right? In this case, we're not going into that, but very simple. We receive a value, we increment the value by 1, right? And then after 1 second, let me actually make this a little bit smaller. After 1 second, we just say like, hey, deliver that value, right? And we're using the feature API here. So let's see how we test this. So we start, every single test class starts with a main, right? Like in Dart, main is the entry point for everything, so it's gonna represent the main of our test as well. And in this case, we're just using the setup. The test package gives us some commodities to do the setup of my test, so I don't have to create this object in every single test, right? So in this case, I can just do it as part of here. So here I'm creating just the API instance, so it's ready to be used anywhere. API doesn't have any dependencies as it exists right now, so I don't need to give it any other like classes or objects or anything. And the first thing that we're gonna test is the increment, right? Like there's, remember, we only have one method in this API. So in this case, it's very simple. When we give it a number 0, we're gonna assert that we get a 1. This is asynchronous code, right? We're using the future API, so at some point we have to specify that it's gonna be synchronous. I'm not receiving the value immediately, and at some point I'm gonna use the await keyword to wait for that result, right? So far so good. There's a typo in here. No, sorry, that's 21, that's correct. So in the case when we pass 20, it's gonna give us 21, and when we give it minus 75, it's gonna give us minus 74. This goes back to the idea of like, how many tests are okay in this case, right? I don't know. It's up to you to decide what's your testing strategy. I decided that for this class, I exercised enough with like a negative number, giving it a 0 and a positive number, right? So far, so good, right? Like this is very simple. This is unit testing. Why is it unit testing and not widget testing in this case? Well, there's no widgets in my API client, right? So we don't need to exercise a UI yet. What am I gaining from separating this API from the rest of the code? Well, first of all, it's a single responsibility class, right? It's only incrementing the value. It's very predictable, right? Like, I'm going to my API client, and the API client is just incrementing. It's not doing something that says, and whatever else. Yeah, it's just incrementing this value. It has no business logic. It's just fetching the data. It's just giving you the data, right? So that's it. Like the only responsibility for this client is to give you the data. We could have an HTTP client in here, deserialize on JSON and all the stuff, but the principles for this would exactly apply the same.
Yeah, and in larger applications, you often will probably have like many API clients depending on what REST APIs you're integrating with and what data sources you have for your application. So in this case, we've simplified it to just one that's called API, but usually you'd have something like, I don't know, like vehicle API client or whatever, like credit card API client. So just keep that in mind.
In this case, if we run the test.
Oh, question.
Have you ever dealt with a situation where you're calling an API where the effect of the API is not like part of the return value, right? Like, so sometimes you call an API, the API returns and says, okay, I got your request, and now sometime later in the future, eventually the database will be updated. And do you know what I mean?
Yeah.
I don't think I'm describing this.
Yeah. I think in those cases, like, it's just important that you capture the contract of the API. So usually with these API clients, you're basically creating like a dark wrapper around an existing either REST API or whatever, GraphQL API. It doesn't matter where your data is coming from, but you're just wrapping that contract and exposing like a dark interface to query that.
As long as you get into a
Exactly. So yeah, you'd still test that by covering all these different cases, but you just might not get a result back in all of those cases. You just want to make sure it behaves properly in every single scenario.
I've had that problem more in widget testing, where the widget can get
We'll see some of that later.
But I think actually that would be one of those cases where like I would try to be more deterministic with my APIs, right? Like if something is happening without me, it's kind of like we're talking about those side effects, right? Sometimes you get the code that you get. I understand, but like
all of Kubernetes is like eventually consistent.
Yeah. Okay, so moving on. How do we run this test? Well, we have a few options. We can use the IDE. In my case, I use VS Code. It has these nice helpers in here, and it gives me like the results in here. So we can see that it's really nicely organized by the groups that I'm giving it, right? So it gives me the class that I'm testing, and the first group that I have is API. Therefore, the first group in here that I can expand and collapse is API. Then I have the second group, and I like to organize my unit tests or group them by method, right? Because at the end, like you're just testing the units. I think it's a good practice because if something fails, I can just put my eyes immediately in Word, like the part that is red. And then here it gives you the nice indication of, hey, like it's green for this test, right? And this is the test description that you give it. Android Studio supports the same thing. And then I'm trying to go to my, here. You can also use the terminal, so let me make this a little bit bigger. And if I go, as you can see, I'm on my API folder, right? Happy testing packages API. So if I run here, pub run test, I'm not using the Flutter command because this is a pure package, so I don't have any Flutter dependencies. It gives you the same summary in here, saying like all the tests pass, right? So this is very simple in theory to test, but let's just recap. We're testing an asynchronous API. If you're coming from the Android world, as I do, like this is one of the biggest like headaches ever, right? Because what do you use? Like Roboelectric, JUnit, Espresso. Wait, actually, there's no good async APIs. We were using RX, like there's a lot of like tooling involved in there, and this is baked within the platform, right? And you just use async and await. As you're using the code, you don't need to learn an extra second framework. Right? You just need to learn how to put the test method in there and the grouping pretty much, right? So very, very simple. Questions so far?
One last thing I want to highlight is, can you go back to VS Code?
Yes.
So it becomes really important the way Jorge named these, especially when tests fail. Because for example, like if you change that middle test to expect like 22 instead of 21, and you're a developer who like wrote some changes and tried to merge them and the pipeline's failing because this test is failing, it's actually a lot more simple to figure out like why is it failing when I go to that failing test and I read, okay, the test says increment returns 21 when value given is 20, and then I get expected 21 or 23, actual 21. Like they pretty much hold your hand and tell you like, okay, actually you meant this probably. Either change the test or change your implementation because you introduced a bug. So naming those tests the way they're named right now, where the group describes the method and then the test describes the intention, actually reads like a sentence, and it should be more like, oh, I'm just reading a sentence and saying like, okay, I clearly broke this one use case, I need to go back and fix it. So it shouldn't be like spending minutes or hours trying to figure out like, how did this test even fail in the first place.
One argument that you would be thinking is like, hey, your real code, like your implementation is literally like 6 lines of code, and for testing, you're writing, let's see, 29 lines of code. Like that's taking me, I don't know, 4 or 5 more times. Not in reality. Like you build a lot of like muscle memory when building testing, especially like when you have this same approach of like set up, act on your like set or like expect the side effects of your testing and then the assertions, right? Writing these tests, as you can see, takes nothing. The IDEs nowadays, they give you actually templates, so the moment you type test, they will spill out like the test kind of like method template for you, right? So don't use it as an argument to say like, it doesn't work. It actually saves you time over time, right? Because now that this is done, I can execute this test how many times? Infinite, right? But if I didn't have this test, then that's a big burden that I would have. And if someone changes this code, I don't know if they're breaking something or not. Coming back to our project, so we've tested this library over here, and this library is a dependency to this library, to my repository, right? So now we're going to jump into the repository and see how we test that layer. And why do we need a repository at all? Well, let's take a look to that. So let me close these classes, these files. Let me collapse the API folder, but now in the repository folder, let's start again with the pathspec file, right? So in this case, we have a dependency, a local dependency that is pointing to our API project. And in this case, we're introducing, on top of test, we're introducing Mockito, right? In Mockito, we said that we're going to use this to control the behavior of our dependencies. So let's take a look to our repository. In this case, I'm exporting the same files and setting up my library, but like the beef of this class is here. And this one is a little bit more complicated. We start with a repository, and we declare like a member variable that it's called API. It's actually a dependency passed via constructor, right? And in this case, I'm asserting that if this is null, I'm just throwing an error. Like I don't want this dependency to be null, right? So for whoever is consuming this repository, they need to pass the right dependency. I have this factory method. This is just like a helper for me. I want to hide the API dependency from the consumer. So by having this create method, I prevent, for example, like my UI layer to have to create an API object. But I can still test this. And finally, I have this get increment message, right? And it returns, instead of an integer, as the API did before, a model that is called increment with message. So if we go to our models folder, we have it in here. It's just a very simple model. It has a value and a message, right? So the value is going to be the value that we received from the increment function. And in this case, then we're passing the string of like, hey, this is an even number, or this is an odd number, right? Like this is very particular to the domain of this application. Had nothing to do with the API that just gives me increments. Therefore, I move this business logic domain into my repository layer. And now you can see how fetching the data and transforming the data, they become two separate projects, right? Fetching the data, being efficient about that could be an engineering problem. Like you want to save milliseconds and all the stuff. This is the layer where like, you can actually start talking to product stakeholders about your problem, right? Like they're the ones that they might say like, I don't want here to say number, instead it should be value, right? That's a product problem, not like a data fetching problem. So
should be localized.
should be localized, and then you can move that into like the UI to localize it. But like you see how separating these things, and even though this is a very simplified example, helps you to organize your code base a little bit.
Yeah, and one other thing is, since these are all separate modules, you could, in theory, when you're done with the API client, for example, someone asked about PayPal earlier, integration with PayPal. If you needed PayPal and you're the first one and you implemented your own PayPal API client, you could just publish it on pub.dev, and then you would no longer use a path to reference it as a dependency, you would just use the version on pub.dev. So then you're doing everyone else a favor because other people can reuse that same code and contribute to it and so on. So this is not only useful for just like splitting up things to make it easier to test, but it's also making it easier to publish and share your code with other people.
So moving on, the first thing that seems foreign right now, like strange compared to what we saw before, is this mock API that extends mock and implements API. Well, this is the way of using Mockito, right? Like, what we're gonna do is like, we're gonna modify the behavior of the API class without having to create a real object, right? Because the moment you have an instance of that object, you don't control that behavior. But for testing, I wanna simulate different scenarios, different cases, so I can validate different paths of execution in my code. So this is the way of saying like, hey, I wanna create a mock object that is gonna mock the API class. And in this case, we just call it mock API. Still honors the API contract, right? Like if you see here, it sounds like it's implementing an interface. This comes from the fact that in Dart, every class is at the same time a contract, like an interface, right? So there's no interface keyword per se, but it's because every class becomes its own interface. But pretty much when we give it a value, right, like we just create a mock API, and then we're gonna be able to use something that's this, or like says something like, when this happens on my mock, then return this value, return this error, or like behave in this way, right? And finally, we saw it before, we create the repository object, and we pass it this mock dependency. So the first thing that we're gonna do, and this is a typo definitely, is that I'm grouping, again, everything by repository. The first thing that I'm doing is grouping or doing a second group with my constructor. So the first thing is, when I give it a null dependency, I actually assert that it's going to throw an error, right? If we go back to our code, what we're testing here is this line of code. So if it's null, just throw an error and make sure that it's of the type assertion error. But if I call the create method, if I'm creating this dependency with a valid API, just assert that it's not null. That's all I need for object creation, right? Then we go to the second step, that is the get increment message. Again, I'm grouping it. I have a test method, very similar to before, right? Like nothing changes in this case. I give it a test description. In this case, returns a message saying it is an odd number if the incremented value is odd. So this is the first thing where we see like a setup of a mock. And in this case, you can see that when I'm calling the API that increment method with any value, I don't care what's the input to that method. I just care about what's the output. I just say like then answer. This is a way of saying like, give me, like return this value, but because we're talking about futures, just give it to me as a later. But in reality, you're giving it in the moment. Just give me the value 3, right? And then we await for our repository call, we receive the result, and then we can do our assertions, right? So again, it's the same 3 steps. Set up, arrange, and then assert. In this case, expect, but like you can interchange those words, right? this case, we said that the result, that value is of 3, and the result that message it says this is an odd number. We go to the second test case. It's the same operation. Instead of a odd number, in this case, it's an even number. So we return a 4, we pass it a 3, and then we said that it's a 4 and an even number, right? Very straightforward. Do this, these are the steps that I always follow. And finally, and this is the tricky part, right? Because we haven't been talking about exceptions, but basically a feature is kind of like, I'm giving you like a gift box, and when you open it, surprise, you could get like a really nice gift, or it could be an exception, right? Like that's the beauty of the feature API. So in this case, we're forcing our mock to return or to throw an exception. In this case, our exception says, oops. So when we call the repository call, if we hit this line, if we didn't capture an exception, we fail immediately here. However, if we catch an exception, it's okay. We're not swallowing this exception. We want to rethrow it or like just throw that same exception. So we just expect that the error received is the expectation that we told our API to throw. So far, so good?
So in the other test, when you're in the box and you're returning stuff, what parameter are you ignoring with the underscore?
So remember that when we go to get incremental message, we give it a value, and that value is going to be used to be given to the API.
Good question.
Yeah. So to be honest, like the way I just did it like, as a showcase that you can use any, right? Like there's another things that you can do with mocks. Like you can assert or validate that a mock is being called X amount of times, or it's never called, or it's being called with certain parameters. That's actually like regarding the question that you had about the database before. This actually could help you to test that, because if you can mock that layer, even though there's no result that is being returned, you can verify that certain calls are happening. So again, we're not talking about widget testing. This is a pure Dart package. It's all about business logic. It doesn't know how we're fetching the data, right? It could be from a network. It could be from a database. We don't care. The repository layer in this case is all about the business logic of my application. And then finally, we get to the fun part, that is the Flutter testing, right? So let's go back to our architecture diagram. We've covered the API, we've covered the repository, and finally our happy testing application, this is the money maker, depends just on the repository, right? So in the same way that we have the API being mocked as a dependency for the repository, we're going to follow the same strategy. I don't care about the API, I just want to force that my repository is behaving in certain cases the way I want it, so it's going to become a mock to my happy testing library. All right, let's take a look to the code. And this is IP protected. Again, like we're going to be millionaires, so don't share it with anyone. I'm not good at jokes. I'm trying. I don't know.
That's a good one.
Yeah. So how do we do this, right? Well, first of all, in our main, we're just going to create a repository dependency. And then we're going to make it a dependency of our happy testing app. The reason why I'm doing this is like because you're not going to be able to taste the main, but you're going to be able to test the happy testing app. So I like to create those repositories at that point, and then I can use them however I want in my application project.
Or you can use whatever DI you want. Like in this case, we're just passing it via constructor, but if you're familiar with different DI frameworks or tools, definitely you can swap them out for.
Actually, yeah, let's take a look because it's important to see what libraries are we using in the project. So we're not using any DI or we're not using any state management. This is not how I would approach like a project, but like I wanted to not to put the focus on like, oh my God, you're using Redux and no one uses Redux, right? It's just about like testing. So I'm not using any DI, just like passing dependencies to a constructor. There's only one class, so there's not that much that I can do. But then pretty much we just depend on the repository that is a local dependency referenced by path. And then in our dev dependencies, we're using Flutter Test, Flutter Driver, Mockito, and Test. So as you can see, this honors this architecture diagram, right? So we said that we were in the main, and we passed the dependency through that in run app. So now we go to our app class. This is very, very simple. So we have a stateful widget, right? Every time we click the button, something is changing on the screen. So I decided that I have some state to maintain it here. And what do we do in here? Well, we have a constructor, and we have the same assert. Ooh, interesting. So if we're going to be able to do widget tests, that's where we're leading, right? Like we're going to be doing widget tests because this is the Flutter stuff. Will we be able to do also like unit tests as well? Well, let's see where we apply those, right? But like, definitely this is going to have, it's going to be important later. And then we just create our state class that again, it's a happy testing app. It's private in this case. It's being used the underscore. Here we have the element of the state that we want to manage in here, right? We're going to start with an initial value of 0. But then pretty much I have a material app with some stuff. But I'm going to have a feature builder. For those that don't know what a feature builder is, it's like I said that a feature is kind of like receiving a gift. The feature builder is your like the person who opens the gift, right? They have the privilege of like receiving the gift, unwrapping, and then they say like, oh, when I'm waiting, I'm just going to be jumping, and if I receive an error, I'm going to present this, and if I receive a success, I'm going to do the other thing, right? So in this case, we just indicate what's the feature that we want to use. So again, we're passing the repository to our stateful widget, so I can access that through my widget, that repository, that increment, get increment message, and we pass it our state variable in this case. And then it has a builder that gives us a context and a snapshot. And from the snapshot, we can check like we're loading, right? We return the loading indicator. We have data, we return the success message. And if we receive an error, we just present an error message. And then a floating action button that every time we press it, we modify the state to increment our internal memory by 1. So this is very simple. The success message is just a center widget with a column that centers two texts, the value and the message that we're receiving. I closed the application, but this is the counter that we saw before. We haven't seen the error message, but it's pretty much like a text rendered in the center that says something went wrong. And then we have our loading indicator that is just a circular progress indicator. So every time I tap, it shows like a spinner that it's loading, right? So with this, let's go back to the test. And in this case, we're going to apply the same technique as before, right? We have a dependency, therefore we're going to mock it. But now, this is not a pure Dart package, so I'm going to need to use widget tests or widget utilities eventually. So we are familiar now with how we mock. So we mock the repository, and then we group our things following the same pattern. Happy testing, we have a group that is constructor. And in this case, notice that I'm using just test. It's not async or anything, the constructor is not asynchronous. So when I give it a repository that is null, I should fail here if it doesn't throw the exception. When it throws the exception, I just check that it's assertion error. We've seen this before, this is familiar, right? Like this is just memory muscle building your test. But now let's go to a more interesting aspect of testing. And in this case, we're using test widgets. But we can see it, like if I didn't say that we were using test widgets here, you probably wouldn't notice that it says test widgets. It's because it's testing after all. It looks very familiar. The same recipe of like set up,
arrange, act.
Arrange, act, and I use different words sometimes.
Or assemble, doesn't matter. You get the idea.
You get the idea, exactly. It's like set up your stuff, do something with it, and then run your expectations. So in this case, look at what we're doing here. The repository was a mock, so we're saying that when the repository is being called with a value of 0, then we're going to return our increment value with a 1, saying this is an odd number. When we do the same thing but passing a 1 instead of a 0, we're going to return a 2 and that this is an even number. You would say like, wow, but that's how the repository behaves. Yeah, but what if I wanted to throw an exception in here? Right? Like this is the beauty of mock. Sometimes you're just going to mimic the same behavior. Sometimes you're going to force it to do something that you just want for your use case. So then we're going to do something that is called await tester.pump widget. So first of all, what is this tester? So this tester comes from the test widget framework, and it's just of the class widget tester, but this is something that is going to let us interact with our widget. I have to say that widget testing doesn't open up a simulator. It doesn't open up any UIPs. If I run it, actually let me run it first. It looks like running unit tests. We're going to see that the output in here is the same.
Which is good because it runs just as fast as unit tests, pretty much.
Yes.
So you don't have to wait for simulator generators to boot up and yeah.
You can see the execution, like it's very fast, right? I just executed the entire application using widget tests. with the speed of unit tests without having to open up a simulator, wait for an Android or an iOS build and things like that, right? Or a Mac OS build. So we said that tester is going to allow us to interact with our application. So the first thing that we do is to pump the widget. It's kind of like, okay, internally in whatever tracing memory that Flutter has, just pump it, just kind of like render it, right? And this is the widget that we want to render, that is the entire application. And then the first frame, right? Like this is just, once you do that, like Flutter is going to paint the first frame. In the first frame, we were talking about like, again, if we go back to our code, we were talking about, we have a feature builder that if we're waiting for this feature to receive a value, it's just going to load the loading indicator. So the first frame is going to be the loading indicator, right? And there are many ways that I can use to test this. I'm just looking for a widget in my widget tree that is of type circular progress indicator. You could, like if you were using keys or something like that, you could do that as well. And I just expect that I'm finding one widget. And then what I do after that is await tester that pump on cell. Think about this. The first frame, we're loading the spin. Right? Actually, I do like this, like it's animated, but it's just one frame, so it's just frozen at that point. I need to tell Flutter somehow like, hey, render the next frame. Or like render until you don't have any animations in the queue, right? Because at that point, this repository code will be finished, will be done, and therefore I will render the next state, the next iteration, or like the next value returned by my feature builder. So in this case, pump on zero is telling the application like finish whatever you have in the queue, and then let's get to that.
Question. So if you were in the mock, you weren't actually doing delays, you were just passing like a feature. The first frame, like I guess I'm just asking about the behavior features. Like the first frame is still like connection waiting.
It depends. So in your feature builder, if we look at the API, you see that there's an initial data. So you could have like an initial data in there. In my case, I didn't pass anything, therefore it's just gonna go with that connection state.
You can also, in the mock, actually say return a future that's delayed by 1 second if you wanted to, and then you can actually pump and give it a duration as well. So you can say pump, but wait for like 1 second.
That doesn't mean that you have to wait 1 second though, but so then after that.
Question?
Yeah, quick question. So, I guess this depends on your implementation, like your specific project, but say your structure of your app, you would have a feature builder on each page that has a circular loading miner.
So I guess this depends on your specific app structure, but say you would have every single page of your application has a circular loading spinner, uses the feature builder. Would you then abstract out your test just to be able to pass in each page and make sure that that works, or would you make sure that each test is only tied to that specific page?
I personally would prefer to not be smart on the test, right? Like, I don't mind actually repeating. Like if I have to assert in 15 different screens that I'm showing the loading spinner, that's okay by me. Because then you don't know how that code is going to evolve, and you don't want to kind of like convolute it into like old code or old features, or like something that to me is a big like code smell is actually having like logic statements like if, else's, in test, for example, right? Like, they should be as straightforward as possible.
But you can also, I mean, in this case it's very simple, so we have just one widget test, but like in that case you might have a separate like stateless widget that just manages like showing a loading state versus showing a loaded state. And then you can widget test that one independently from everything else, for example. So it depends on how, like you said, the use case, because you could in many cases decompose even further and have smaller, more focused widgets, and then these widget tests become even simpler.
Yeah. So we were talking about pump on seller is kind of like telling the Flutter system like just move until you don't have anything in the queue, and after that we kind of said that the value received is 1, and then the text was like this is an odd number, right? If I tap the button, right, like I find the floating action button, and with the test I tap on it and call again pump on solo, I'm gonna do that animation that's in process again, but now I'm actually executing this mock eventually, right? And I can assert that the value is this 2, that's what we're rendering here, and the message in there is that message, right? But now I can even test by using this mock. I can test the failure scenario, which, by the way, we will never get, for example, in the real code, because our API client, that is the one that could be carrying on that error, it's hard-coded, right? But me, as a consumer of that API, and as a consumer of a feature API, I don't know that. Ideally, that would be a black box to me, that it doesn't tell me like this is never gonna throw an error. Therefore, I wanna make sure that my code is covered for that case, because maybe eventually the API class changes, and that API, that feature API was telling you like, this might throw an error, so why not cover for that case, right? So in that case, we do that, we throw, as you can see, like we answer with a feature error that says, oops. We pump our widget. The first one that we render is the circular progress indicator. We pump answer again to get like that result. In this case, we're asserting that we find the text something went wrong, which if we go back to our project, comes from this error message widget saying something went wrong.
Yeah, so if we wanted to, we could get even more like extreme and have a widget test that just renders the error message widget and make sure that we see something went wrong, one that renders the success, and make sure we see the test there. We made those private just so we can hide that and simplify this demo, but like in large applications, that definitely be something that can do.
So this is how you run the test with Flutter Test. We're talking about the randomized seed. So in this case, for example, this is a way to do that. I'm just passing no pub. I don't want to download like Flutter packages yet again. And I randomize it again, and in this case, hope for the best, it passes. This execution is going to be different, but it passes again, right? Because there's no state between those things. Like the application itself has a state, but like every time you execute a test, you go through the loop again of like setting up, tear down, and all the stuff. So every test execution is independent from the previous one. Okay, so with this, we've covered widget tests. But like Felix and myself were really like test lovers, or I don't know how to say it, enthusiasts. So we went one step ahead and we actually added test driver, Flutter driver support for this. So Flutter driver, now what's going to allow us to do is we're going to launch a host, could be a simulator for Android or iOS, our Mac OS application, and we're going to actually exercise, we're going to see how the application is doing like monkey testing. This would be the equivalent of Express in Android, XCUI test on iOS, I don't know.
Protractor,
yeah.
Selenium.
So this looks a little bit different. It doesn't follow the same testing structure as before just because the instrumentation part is a little bit different, right? He has a main folder, or like a main entry point here, and we have it in the test driver. We just say enable Flutter driver extension, so this is going to allow us to interact or go through the widget tree and find items without actually accessing, and this is very important, like this is black box testing, right? Like I don't have access to the code at this point. We say that the application is pointing to our main file. And from here, the way we drive or we write this test is by getting this Flutter driver, we connect to it, right? So Flutter driver is kind of like an instrumentator. And once we don't need it anymore, in order to not to have like memory hanging and causing problems, we just close that driver. And this is very, very simple.
Before you even go further, one problem that you might have that we literally had preparing this is, yeah, you can cover it.
So again, because you don't have access to the code, you cannot import the Flutter Test package because Flutter Test is Flutter code, right? And that breaks the idea of being a black box. So instead of using the Flutter Test package as we did before here, it's very important that we use the pure test star package.
Yeah, make sure you have no.
It's weird because I can just put Flutter Test and Flutter Test in there and it's going to compile, but it breaks at execution time. And we were like, what's going on? We cannot deliver this, let's go back to Chicago. Just for an import. So the way we write this test is very simple. Our initial state, as you can see, it's all asynchronous. So we use the async in our test declaration. And then we await pretty much for the Flutter driver to do things. And because Flutter, like the feature API is very simple, we don't have to, like if you're coming from the Android world, you don't need idle resources or anything like that. Just wait for things to happen. And Flutter can actually take a look to, well, in this case, Dart, take a look to its execution queue and see if there's something in progress or not so you can keep moving forward, right? So in this case, we're gonna get the text value 1, we're gonna get the this is a number, and we're gonna tap on the floor in action button finder. Like we have it here, so we didn't have to tap the same thing many more times. And pretty much it's incrementing like now, okay, now we're in the value 2, now we're in the value 3, now 4, 5, 6. In this case, it's integration test. As you've noticed, I'm not actually mocking anything, I'm integrating everything. You could have, like, there are many strategies for doing this. Like you could have like a fake server. A lot of people, they do like an HTTP server or something. You can try to mock your API client and all that stuff. That's up to the team to decide, but like at this point, like you just want to try to mock as less as possible. That's my opinion at least. And the way you run this test is actually like in the README of the project.
Hey, we already have 1 star.
It wasn't me, I promise. We added how to run every single step, test suite, sorry. So for integration test, I'm just going to copy this. I'm going to come to my terminal. I'm going to paste it. And let's see what happens. It's going to be very, very fast. Again, like, it's going to be UI testing, but like, it's very, very fast, right? So at some point, you just could see like a frame or 2.
Yeah, you might not even see the
You're
text.
mostly going to see the loading spinner, but like that's good, right? Like you don't want to have, there you go, ooh, 4, 5, 6, done. Alright, so this is a little bit more expensive. The setup is a little bit harder to do, right? Like if you're in a CI/CD environment, you usually have access to your CLI, but like GitHub Actions doesn't give you like iOS simulators for free or things like that. It's a little bit more expensive in terms of execution. Like the feedback that you get from this takes a little bit longer, but you're executing a broader scope of your application. So it's up to you and your team to decide like where to invest, how to be efficient, what's important, what's not. But like I think you have these options. As you can see, it's very simple. It's actually fun. Believe it or not, at least I enjoy it a lot, and it makes me a lot of confidence. Like I do not consider myself like a smart guy. Like I'm a very kind of like, I like finding patterns and strategies in the way I do things, and testing is one of those strategies that helps me to try to tackle complex problems into a way that is understandable to me. And if it's understandable to me, it will be understandable for everyone, believe me. So yeah, it's just another tool in your toolset. Please use it. Have fun with it, break it, fix it.
One thing that is really useful about integration tests is like how many times have you had designers come to you and ask you like, oh, can you send me a screenshot of that one screen when you get that error that one time that we've never seen in production before? And like, I don't know about you, but that's happened to me before, and I'm like, oh, okay, now I need to figure out like, how do I get that app in that state just so I can give this one person a screenshot that they need, or I need to like change the actual implementation to like force it to go into that state. And with integration testing, you can take screenshots along the way, and you can actually generate reports, publish those reports, and then have a place where anyone can go at any time and see, like, this is right now what our application would look like in every single one of these scenarios. And that's really powerful in my opinion, because now you save yourself the time of going back and forth between developer and designer. Like, developers don't usually love finding code and taking screenshots of it. Oops. So like that's one less thing that you have to do as a developer, and that's one less like step that people have to hop through, and things could get outdated, yada yada yada. So it's a really cool tool for things like that too.
Yeah. So
and yes,
we open source this library that it does exactly what Felix explained. Like it plays very nicely or integrates with Flutter drivers, so you can take screenshots and then analyze the performance of your application. By performance, I mean like I'm rendering 60 frames per second, right? Like that's what Flutter promises. And if I don't do my code properly, I might have junk somewhere, so I might be missing frames, and I don't want to be missing frames, right? At least I don't want to have that code running in production. I want to be the first line of defense that makes sure that like the customer is getting what they deserve, right? So we open source this library called OSI. It's from our VNW days, but like we maintain it, so yeah, that's what we're doing there. And with that, I apologize, we're not done. Because we still need to talk about how to do this in a more automated way.
Yeah, so instead of having to manually run all these tests after every change and make sure that everything works works. Like, you can't really rely on people remembering to do that every time, especially as teams grow and you have like people in London, China, all over the world. So automating all of this and making it so that no one can forget, it's just done by a computer is really, really important. And so we want to use automation to enforce things like best practices. For example, like making sure the code is formatted or linted, or you run like the Dart analyzer, make sure there are no errors or warnings. And also prevent bugs by running all the tests and make sure that all the test cases that we have written are covered and passed. And lastly, save time. So you don't want to have manual, or limit at least the manual regressions that you do, because as you can see, like Flutter driver can run a lot faster than a human can in terms of tapping UI and making sure that things look the way they do. So capitalizing on that and taking advantage of computers as much as possible is definitely a huge win. So we will talk about Codemagic. So some of you said you've used Codemagic, a lot of you haven't. What is Codemagic? It's pretty much CI/CD that's designed specifically for Flutter. So they do support other platforms, but their big thing is Flutter and making it really, really easy to integrate a Flutter project with a pipeline in Codemagic, so you can do things like running tests on every commit. You can do things like automating builds, deployments to the App Store, Google Play, test flight, even like notifying Slack or other messaging channels that builds have been pushed, that type of thing. And they make this all like really, really simple, so you can do it through their UI, or you can also do it as code, so you can commit the configuration file to your repo and basically maintain that in-source control so that it's not like, if you're worried about people messing with the dashboard or something like that, you don't really have to worry about that if you don't want to. So possibilities are endless, and we're going to show you super simply how to actually use Codemagic in this project. And you can, actually, if you go to the GitHub project, you can see we have a badge on there that links to the Codemagic build. So you get this cool badge that'll give you the status of the build at any point in time, so you can monitor that. And we'll just quickly, can everyone see this? Maybe make it a little bigger. We'll just quickly go through the steps that we have in Codemagic. And obviously you can customize this to your heart's desire, but pretty much if we take the last build, which passed 4 hours ago, we can see the steps that ran on the right. So at the beginning, Codemagic has to prep your server, so you can choose what kind of hardware you want it to run on. They have Mac Pros, Mac Minis, all kinds of different configurations, so you can choose based on your needs. They'll pull the sources that you need, so Flutter, your code, whatever else. You can also select to cache certain dependencies, so you're not downloading the same things over and over and over again, and Codemagic will actually cache that for you. We'll install the dependencies, so all of our pub dependencies like the test, Flutter Test, Flutter driver. And in this case, we've configured a testing stage. So it will actually run all the widget tests in our project, and it will also run the integration tests for our project. So it'll run those on Mac right now. We'll show the settings in a bit. But you can see like we have these 3 widget tests that pass. We even see the names. We see this nice little green checkbox. And if any tests fail, you can select to fail fast, so have the whole build fail immediately, or you can have the build continue so that you can go back and see like everything that failed later on. If you're coming from a legacy code base and you're trying to integrate something like this, it might make sense to just have the test run but not fail the build right away, and then over time you can try to address all the failing tests. And yeah, and then we have these build iOS and Android, so by default, it'll just actually build in debug mode for iOS and Android, and it'll archive an artifact so you can post that somewhere internally or upload it yourself if you wanted to, but you can take it a step further and actually publish to Google Play or Test Flight automatically. So they'll do the code signing for you, and they'll handle pretty much everything. So you can have that either be a click of a button away or automate it so that when you tag a commit or when you push to master or push to a release branch or whatever, it will do all those things for you.
And let me tell you, Android is easy, but iOS,
yeah.
like the signing process is...
We definitely have had trouble with iOS in the past, so this is a really nice thing to have. And then, yeah, the publishing stage, which is just gathering artifacts right now. It's not publishing them to Google Play, obviously, but we could set that up with developer accounts. And then this cleanup, which is just deallocating all of the memory for the server that you were just using. And that's pretty much it. So you can see on the left the artifacts. We have a log of any output that got printed while the tests and workflow were executed, as well as the APK and the app for iOS. You can also, like, if you ran code coverage and generate a code coverage report, upload that as an artifact so people can just like click on the build and see what's the report. And let's just jump into actually the settings so you can see what it would look like.
Do I have access to the settings? I think I do.
Oh no. Okay, that's fine. We won't go into the. Yeah, pretty much all I was going to show, I guess Jorge doesn't have access to the settings, but all I was going to show is how simple it is to customize. So you can do things like adding custom bash scripts if you want to add like any custom logic for maybe if I run coverage and my threshold drops below like 90%, I want to fail the build, you can write a custom script in your build pipeline to do that for you. Maybe you want to like send an email every time the build fails, so a certain like list of people you can write or customize the pipeline to do all that. So all of it is really nice and simple in terms of this UI, but you can also export as a YAML file, and that's currently in beta, but it should be coming out in production soon, so you'll have that configuration as code, and check that directly into your repo, kind of like Circle CI, Travis, and all those others. So.
I have a question here.
Yep.
So you say can do this tool can also do the publishing
Yes. Yes.
to both the Google
Yes.
stores. So can you show me to publish this one to the customer?
You want me to? Or you want to switch computers?
Kind of this way. Can we start recording? What's the
I can.
I don't have anything in here.
Yeah, they will save a lot of trouble.
Yeah, I mean
it's
very easy. Like they give you like, do you want to sign in an automated way or with your manual certificates? But like pretty much you generate the certificates that you might need locally in your computer. Put them there, and then it does the signing for you. And you can publish to App Center, like, or Firebase distribution, or like directly to App Store and the Play Store. But like, it won't publish directly to your final customers. Like, it will go to the alpha or the beta track or something like that. You have the final push to do, but like, it will do the heavy lifting for you.
okay.
Yeah.
So all the signing process.
Yes.
Yes.
The build process. They're
Yes.
done. Okay. Yeah.
Yeah.
That's great. Yeah.
And the good thing is, like, if you're like more comfortable with UI dashboards and all the stuff, you can use this tool. If you're more comfortable with Coda's infrastructure, right, like GitHub Actions or Travis, they also give you that option with a YAML file, so you get the best of
everything's going forward really quick. Really risky. We might need you. So, just for the sake of showing what it looks like if you create one of these yourself, hopefully it comes back. All right. Oh. I don't know if I can use. All right. So, basically you have this little settings guy here, and now you can customize things like what triggers my build. So you can say if a certain pattern is matched in terms of branch, or if a tag is added. You can have automatic triggers, so anytime I push anything, everything runs. And you can pick different workflows, so you can make a workflow for running your tests, make a workflow for publishing to Google Play and the App Store. You can also set up environment variables, so like keys for APIs.
Like things that shouldn't be in the, like, as part of your repository, like your source control repository.
Yes, and Martin from Codemagic wanted us to assure you that everything uses AES 256 encryption and is secure, wiped out from the servers after, so you don't have to worry about security with Codemagic. You also have the dependency caching, so a lot of times you don't want to wait as long, or you want to save yourself a few minutes and not re-download the same things over and over again, so you can tell what directories to cache across multiple builds.
And that's important because the pricing model is that you have 500 minutes per month for free.
So does it include all these functions?
Yes.
Yeah, all this is included, right? And if you use it for less than 500 minutes per month, you don't pay anything.
Yeah.
If you need it for more, then you put your credit card number and that's it.
Yep. And so for tests, you can see it's as simple as a couple of checkboxes. Like if I want to run the Flutter analyzer every single time, I can just check this box. If I want to only run widget tests and not integration tests, I just uncheck that box. Like there's no code, nothing that I need to really mess with here. If I, again, like I mentioned earlier, want to not fail the whole build, if my tests fail, I can just uncheck that one box, save, and I'm good. We can also tell it what kinds of simulator or emulator to run on, and they have the option of AWS device farm. So this is really useful if you're trying to profile. If you want to run the app in profile mode and actually get real data on the performance of the application, you should always do that on a real device in profile mode. So this is where this would come in come really in handy for things like that. You can see here we're passing the same arguments that Jorge passed when running Flutter driver, so we tell it where the actual main is. And then in our build, can say we also want to build for web, for example, or for Mac, or for Linux, or whatever. You can also build and have app bundles on Android to reduce your bundle size, so you're not generating an APK. And then debug versus release or profile. So we have ours in debug mode, but you can certainly build for release if you want to have perfect performance, 60 frames per second, or profile if you want to gather real data and have like all of that information to actually like figure out how energy efficient or how performant is my application. They have like Xcode version, arguments, so you can control all that. And then lastly, here's the cool stuff that people are asking about, like if you want to configure code signing for Android or iOS, you can just go in here, pick either manual or automatic. Automatic is really easy. You just have to put in the credentials for the iTunes account. So you can create like a separate account that's like a tools or CI account, give it permission to publish, set those up in Codemagic, and then you're good to go. You don't have to worry about signing manually, or you can do the manual signing as well. And yeah, there's a bunch of other integrations like Slack, email, notifications, things like that. And what I was mentioning earlier is you can actually download everything as a YAML. So if I download my configuration, it's going to want to open an Xcode because it loves Xcode. But let's see if I can make this bigger. You can see this workflow gets generated based on our configuration settings in the UI in Codemagic. So now we can take this file, check it into source control, and it'll use that file as our workflow every single time we make changes. So as a developer, like if I don't want to run Flutter packages pub-get, for example, I can just remove this line, check it into source control, and that's going to modify our pipeline moving forward. So you can control all of this via code and not just the UI if you want to be more rigid and have really fine control.
And the good news about having it as a like in code is like if it removes that line and I'm reviewing that PR, I can say like
you can say no, no, no. Yeah. So any other questions about Codemagic, dashboard, capabilities, limitations? Yep.
So you said you use GitHub Actions. So what are like the differences? Why in that case you use GitHub Actions or the client?
it's just a matter of preference for like you can do everything with Codemagic. Actually, I feel like the part where like they do the code signing and all the stuff, it's great. Like we could do everything. It's just like it depends on like what are your requirements, or like in our case we work with clients, and sometimes like they set up GitHub Actions for some other projects with a different technology, so they're familiar with that. They're like, okay, the part that we can run in GitHub Actions, like code signing and all the stuff. GitHub Actions is more like going to the raw steps, right? So that definitely like Codemagic is easier for that, but I think Codemagic when it comes to automation checks all the boxes for Flutter.
Yeah, it's kind of like an all-in-one, but it really shines in the CD, like the continuous deployment, as opposed to CI, like you might be able to accomplish that with a variety of tools. It's just harder to do what Codemagic does in terms of continuous deployment with a lot of other tools.
So if you were just a native developer, I would add Flutter to your project just to use Codemagic with code signing.
Yep. Any other questions about Codemagic? Yep.
Yeah, how long does it take to build? Do you guys build on every release, or how do you use it?
It's a good question. Do you want to take that?
I think it depends on your release strategy. When we're at BMW, every commit to master was actually deployed to App Center eventually. So we were like very into like pretty much like chunk-based development, and like you could get the latest of the latest at any point in time, just to like different sets of users. There's people that they like to do like every Friday or every Monday, or like every time they every time they push or a tag, right? Like it could be tag driven based, something like that. It depends what's your strategy and what you do. You could even follow, like in this case, Git flow, right? Like so every time you merge into develop instead of into master or something like that. In my case, I like to push as often as I can. Just maybe like to an internal set of users, right? But like I like to have immediate feedback of the build.
Yeah. In terms of how long, I'd say like most builds that do everything from building, analyzing, running all the tests, and publishing probably take like what, 10 minutes?
10, 12, 15, yeah.
So you can get the whole suite in 10 minutes. So as long as you can wait 10 minutes to merge a PR, you can get all that automation.
And one thing that we haven't explored is actually by dividing this project into tiny modules, right? This, of course, it was like just for the example, right? But like, when you're gonna have more complex repositories and API clients, you can run workflows in parallel, right? Like, so you could have some of these duplicated just to focus on one part of the UI or something like that, so you can be efficient and smart about what do you execute in parallel or not.
And again, you can bump up the hardware if you need like more powerful hardware to run things faster. It's always an option.
Yeah, especially like for Flutter drivers, right? Like you might want to have like the latest macOS, but like for pure Dart packages, whatever images are available works.
Yep. Question.
I don't know if someone faced this issue or not. Sometimes when you done with the Flutter project, the app size will be very large. So does Codemagic solve this problem if we want to publish it to iOS or
So I love this kind of questions. I love getting reports and metrics and data. So you can track the size of your APK, your bundle, your IPA, not like through Codemagic directly. Like I think that maybe the artifacts they publish that information.
Yeah.
But you could actually run your own scripts to say like, hey, this size, this like bundle or whatever is way bigger than the threshold that to me is not acceptable. Mark this build as a failure. That's something that we were investigating at BMW, right? We had like a very, or at least you can gather like historic reports of like how you're growing. Because if you introduce in a PR a change that goes from 20 megs to 80, what happened is you're using a dependency that is super big, right? So one of the good things about Codemagic that we didn't mention that much is like at every step, like between building, testing, signing, and publishing, you can run pre and post scripts, so you can do whatever you want with that information.
Yep, so we can add stuff before testing, we can add things between testing and building, we can add custom scripts after building, before publishing.
Can you click on one of those?
Yep. So it's pretty much up to you what you want to do here. But yeah, like Jorge said, I think in terms of like having the smallest possible size, you should be able to accomplish that with Codemagic because it's going to build, especially if you're changing to release mode, it will build the smallest possible binary for you. So like you're not going to be creating a bloated application. Obviously, if you have dependencies that are huge, it's going to make your application bigger. But you shouldn't be like larger than any other Flutter application. So like you said, if you start from the very beginning monitoring the bundle size, you can definitely make that part of your pipeline and like say, oh, if I bump up by more than like 5% or 10% in one merge in terms of APK or IPA size, then something's probably wrong. Or like make sure you're intentionally doing that for something very special.
There's another good thing about Codemagic and the Flutter community in general is like it's very open and like feedback driven and actually like customer feedback driven, right? Like, and you are a customer in the same sense that Felix and myself, we are Flutter customers. So if you open an issue on Codemagic, like they have a Slack channel like on Twitter or whatever saying like, hey, I want Codemagic to track like size reports for my deliveries, and you get like enough thumbs up or like likes from the community, or like maybe the team at Google they say like, oh yeah, that would be amazing, right? Like, it's gonna take them like not that much time to implement it. Actually, for example, we had a conversation with them almost a year ago. It's like we love Codemagic, but like we love also like Coda's infrastructure. So not having that is kind of like a bummer for us. And 2 months later, they're like, hey, check out our latest beta feature, right? So that's very nice to see, like, you're important to them.
Yeah, join their Slack. They're very active and post announcements constantly in Slack, so you can be up to date with like the latest features that they're working on. Or since the community is so tightly knit, your feedback really means a lot. Like they will actually take that into consideration for short-term goals. So you don't have to be worried about it taking like years to actually change their infrastructure. They're very agile and they are very flexible. So. Cool. Any other questions? Yep, go ahead over here.
Curious, have you guys tried test-driven development?
That's a good question.
Any take on that?
So that's another tool available to you. I think it's, so to me, like I like to do that once I know the end result. Like if it's the 5th, 6th time that I'm working on the same kind of like type of logic, I feel very comfortable. But like sometimes coding is an exploration phase where like, you know what's the end result, but you don't know how to get there. And therefore, like, you don't even know yet how to structure your test, right? So for me, unit tests are usually easier to tackle as an activity. or like widget tests, like I don't even know what widget I'm gonna put here first, right? So let me figure that out first. Let me make sure that it works. I can do my smoke testing manually, then I can write that test. To me, it's another tool that you should feel comfortable to use it and decide when you're being more efficient or less efficient or more effective, right? Like, to use it. But I think it's important to know what's there. And I think that could come down to a personal preference.
Yeah, I was going to say, like, I know people who love it and people who don't, and I don't think like one is necessarily better than the other. As long as you're writing tests, I think that's all we're here to say, like, please write tests. It should, like, you should never be afraid to write tests, hopefully. That's the big takeaway here. But, like, everyone has their own personal preference. Personally, I like to write the implementation, then immediately write the unit tests, and that'll help me while it's still fresh in my mind, catch any edge cases or find any bugs. And then over time, like, it's a kind of like an unspoken thing that anytime there's a bug, there has to be a test added for that bug, so that that never happens again, basically. But in terms of the approach, I think TDD is totally valid, and like if it works for you, keep doing it. It's just something that both of us, like, I guess it's personal preference.
And even if you're interested on like behavior driven development, you see that Flutter driver is kind of like getting into that world, right? That's something that a stakeholder might understand without having to write the code. But there's even a library that is for Capybara, like adapted to, I don't know if it's just Dart or Flutter. I don't know how active it is, I just know that it exists. We explored it at some point, but again, it's another tool that is there. If you love Capybara and you feel like the support is not there, jump into like the project, join it, fork it, open a PR, thumbs up, emojis, like everyone is happy, right? So,
yeah. Great questions. Anything else?
Could you comment a little bit on obfuscation with Codemagic? How does that work, and is that supported, et cetera?
So obfuscation of your code, I don't think Codemagic has nothing to do with obfuscation, right? It's just like a CI/CD tool. Obfuscation in Dart is a little bit different. There's some very rudimentary docs out there on how to achieve obfuscation. It can be done. I think it's just like, it's one of those things where like the community hasn't put enough emphasis, and therefore like the Flutter team, or the Dart team in this case, right, because it's part of that, they have decided like, well, if this is enough for now, let's see if we have a customer that needs it or something like that. So if it's something that is important to you, definitely like reach out to like check what's up there, because it's doable, it's just not super like detail oriented as the documentation.
Yeah, you can definitely do it. It's not like a click of a button though, but yep.
Is Codemagic specifically for Dart code or for Flutter?
So no, they support React Native, Android, iOS, I think maybe some JavaScript web frameworks besides React Native, but they're very focused on Flutter. Like, it's part of a larger company called Code, but Codemagic is their product that's like really targeted at Flutter for CI/CD. So they're one, if not the first one, I think, that had a tool for Flutter. So that's definitely like their first and foremost priority, I think. Can't speak for them obviously, but that's kind of like been their focus, and they're very active.
They're really endorsing Flutter as language then, it looks like.
Well, yeah, they're really backing Dart. I think like they've been at every single Flutter event in like I/O, Flutter Europe. They're all over the place constantly, like trying to meet more people in the community, get your feedback, trying to convince more people to give it a try. There's a lot you can do for free with Codemagic, which is really awesome, especially if you're doing like a side project or have something that like is a hobby and turns into maybe like something real. Like Codemagic is awesome for those types of things because the overhead is very small for getting started. So, but yeah, I think they're pretty focused on Flutter, but they aren't exclusive to Flutter. You can use it for other things as well.
Yeah, so pretty much these days with either Codemagic or other alternatives, they make CI/CD very approachable for everyone, even if you don't want to spend any money, right? So it's now like, I feel like a couple of years ago we had the excuse like, well, if this doesn't work, you know, like, whatever. You could just kind of like made up an excuse. Nowadays, like the integration is just away from one click.
Yeah,
Codemagic, it's zero, like.
We didn't show this, but it's as simple as you sign in, link to GitHub, and then it'll show you a list of the repos, and then you just click on the repo you want and say build. That's it.
Here I did it in about 10 minutes.
Yeah.
Like,
It's, in my opinion, like it's one of the fastest to set up. Like there's almost no setup. You just need to link it to GitHub and tell it what repo you want it to use, and then that's it. And the default settings are pretty good for most people.
And even if you had a more complicated setup with flavors and, I don't know, like we had a, you name it, like it can be very tricky, that build system, because you have to target like, maybe you're working on a white label app, right? And you have like multiple apps within your app, or like multiple flavors, and you wanna release one to App Center for internal testing, the other one to the beta track of the Play Store, and things like that. Again, like you can all, like, there's no limit in that case.
Yeah, it's kind of like you have all the pieces, you can choose how to arrange them, but they've done like most of the heavy lifting for you in terms of integration with third-party services. So that's usually the hardest part in our experience. So that's the nice thing about Codemagic.
You don't have to know this at the top there. I can find out myself. But you said it integrates GitHub. Do you know about Bitbucket?
I
think so. I think if you go, the moment you go to the main Codemagic app, they say login with GitHub. I'm pretty sure that they support Bitbucket.
It does, I've used it for a side project.
All right.
Yeah.
All right. Thank you.
GitLab, Bitbucket, GitHub. Yeah.
And if you ever have the chance to meet the Codemagic team in person,
Yeah, definitely.
they're one of the best things of the Flutter community for sure. Right? Like they're super nice, super invested and involved with the community. They were sponsoring Flutter Europe. But like even the fact that we're here coming from Chicago, we don't work for them. That's a sign of how involved and how proactive they want for people to use it, and they give you a lot of things for free. But also just to love like the product itself.